Hello friends, this is the second video for the exercise 2.4. This exercise is big one and the topics is also big and it is up to some extent difficulties also. In these topics we are learning the given function is increasing, decreasing and the maxima and the minima. All solved examples are very important. By my experience up to this, the number of the times these solved examples are asked in the board exam and also the CET exam. That's why I am taking all the solved examples. My video will be up to the 1 hour only. Then and then you can learn this very clearly, because this is the biggest part that I think that all these part 4 to 5 parts will be there for the exercise 2.4. Now we'll start the example number 5, solve example number 5. Two sides of a triangle are given. Find the angle between them such that the area of the triangle is the maximum. I mean, this figure ABC is a triangle. These are the sides. Small a is the side angle opposite to angle capital A. Small b is the side opposite to angle capital B, and the small c is the side opposite to angle C. Let triangle ABC, let ABC be a triangle. And their corresponding sides are, that is a AB is a small c, AC is a small b. Let delta be the area of the triangle, that is 1 upon 2 BC into sin A. This is the formula for the area of the triangle, and the sides are given. Now differentiate this with respect to A, that is a d delta upon dA is equals to BC upon 2. What is the derivative of sine of A? It's a cos of A. Now for maxima or minima, every time we substitute, that is, we find the values d delta upon dA is equals to 0. And here is also BC upon 2 into cos of A is equals to 0. It means that the B and C is not 0, cos of A is equals to 0, but it is A is equals to pi by 2. Now differentiate with respect to A, then d2A, d2 delta upon d2 dA2 is at A is equals to pi by 2 minus BC upon 2 sine of pi by 2. And that is equals to minus BC upon 2, which is the negative. Therefore, when A is equals to pi by 2, the area of triangle is maximum. This is the condition for the area to be the maximum. When the area angle between the sides is pi by 2. Now again we will see this here. See this here. Let ABC be a triangle. Let the given sides AB is equals to small c, AC is equals to small b. Let delta be the area of the triangle. Delta is equals to 1 upon 2 BC into sin A. Now differentiate this one with respect to A. D delta upon dA is equals to BC upon 2. Derivative of sin of A is a cos of A. For the maximum or minimum, we always equal, that is that it's a first derivative equal to 0. Therefore, d delta upon dA is equals to 0. What is its a derivative? BC upon 2 into cos of A is equals to 0. Therefore, cos of A is equals to 0. But when the cos A is 0, the angle is pi by 2. Now differentiate this question number 2 with respect to again A, and derivative of cos of A is a minus sin of A, and its a value at A is equals to pi by 2 is a minus BC upon 2 into sin of pi by 2, and sin pi by 2 is 1, and that's why we get the minus BC upon 2 is a less than 0, and hence when A is equals to pi by 2, the area, this is the condition for the maximum. When it's a second derivative test, that is it's a negative, then the area is a maximum. Therefore, when A is equals to pi by 2, area of the triangle is a maximum. Hence, the area of the triangle is maximum when the angle between the sides is pi by 2. This angle A must be, that is equals to pi by 2. Then the area is maximum. Now next problem. The slant side of a right circular cone is L. Show that the semi-vertical angle of the cone of maximum volume is a tan inverse of root 2. Let x be the height of the cone and r be the radius of the base. Now we know the formula, that is L square is equals to r square plus x square, that is r square is equals to L square minus x square. X be the height, this is the perpendicular height, r is the radius. So the r square is equals to L square minus x square. Let V be the volume of the cone. Then what's its volume of the cone? That is 1 by 3 pi r square into x. That is equals to pi by 3. The value of r square is L square minus x square into x. Now simplify this. You will get V is equals to pi by 3 in bracket L square into x minus x cube. Now differentiate this with respect to x. X is the variable because we have given that that is the volume of the cone is a maximum. Therefore, its first derivative, that is a dv upon dx, is a pi by 3. Derivative of x is 1. L square into 1 is L square. Derivative of x cube is a 3x square. Now to find out maximum and the minimum, we always equals to the first derivative equal to 0. For the maxima or the minima, here we have the case of the maximum, and that's why we are writing dv upon dx is equals to 0. Therefore, L square minus 3x square is equals to 0. Therefore, x square is equals to L square upon 3, and that's why x is equals to plus or minus L upon root 3, or x is equals to L upon root 3, or x is equals to minus L upon root 3. For the stationary point, that is the x is not negative, that is x is not equals to, length is not negative, that's why we are not considering the value minus L upon root 3. And we are considering x is equals to L upon root 3. Now differentiate this second one with respect to x. This is the d2v upon dx square. Now what will happen? The derivative of L square is 0 because there is no x there. It's independent of x. And derivative of 3x square is a 6x and it becomes, that is a d2v upon dx square. Again there is a pi upon 3 and it becomes, that is equals to minus 2 pi x divided by 3 and it becomes 2 pi x. This is equation number 3. But we have the value of x, that L upon root 3. Now if we substitute here it, as we are getting that this value is negative and this is the condition for the maximum. For the maximum, this is the condition for the maximum, that is this is called the second derivative test. When the second derivative is a negative, it is a condition for the maximum, that particular value of the x. Therefore, the volume of the cone is a maximum when the height of the cone x is equals to L upon root 3. Put L is equals to x is equals to L upon root 3 in equation number 1. And here is equation number 1. This is equation number 1. L is equals to, we'll substitute x upon root 3. Then R is equals to, in root of L square minus L upon, that is a root 3 bracket square. And after simplifying, you are getting R is equals to root 2 upon root 3 into L. Let alpha be the semi-vertical angle. That is alpha be the semi-vertical angle. Then what will happen? That is a tan of alpha. The definition of the tan alpha, that is a opposite side upon adjacent side. That is opposite side is the radius. Now if we see this, draw this figure, and you will notice that if we have, this is a cone, this is a circular part of the bottom, and if this is the perpendicular and this is the alpha angle, and this is a radius and this is the height. Therefore, that is a tan of alpha is equals to root 2 and alpha is equals to tan inverse of root 2. Now I can see this. The same problem I am repeating here. The slant height of a right circular cone is L. Show that the semi-vertical angle of the cone of maximum volume is tan inverse of root 2. That is, for the angle tan inverse will require the opposite side and the adjacent side of the semi-vertical angle. That's why we want to find out its radius and the height. Let x be the height of the cone and r be the radius of the base. So r square is equals to L square minus x square. This is equation number 1. Let V be the volume of the cone. V is equals to 1 upon 3 pi r square into x. Therefore, V is equals to pi upon 3 in bracket L square into x minus x cube. Now differentiate this with respect to x. The derivative of x is 1 and x cube is a 3x square. Now here is again the first derivative, that is equals to 0. That is L square minus 3x square is equals to 0. Therefore, x square is equals to L square upon 3, taking the square root on both sides. Then you will get x is equals to L upon root 3, or x is equals to minus L upon root 3. But the length cannot be negative. Therefore, we take the value of x is equals to L upon root 3. Now this is our first part. Again, differentiate with respect to x. That is, we find out the second derivative. d2v upon dx square is equals to for the maximum differentiate again equation number 2 with respect to x. Then you will get d2v upon dx square is equals to minus 2 pi x. This is the third one. Now, for x is equals to L upon root 3 from third, we get d2v upon dx square is equals to, at x is equals to L upon root 3, that is equals to minus 2 pi L upon root 3, which is less than 0. It is negative, and this is the condition for the maximum. Therefore, the volume of the cone is maximum when height of cone is x is equals to L upon root 3. Now we'll find out the angle. That is x is equals to L upon root 3. What we have, that is r is equals to in root of L square minus x square. That is L upon root 3 bracket square in root of L square minus L square upon 3. That is 2L square upon 3. That is equals to root 2 upon root 3L. R is equals to root 2 upon root 3L. And that's why you are getting, let the alpha be the semi-vertical angle tan of alpha is equals to r upon x, that is L root 2 upon root 3, the value of r, upon x is L upon root 3, and the overall that is equals to root 2. Therefore, alpha is equals to tan inverse of root 2. Now we'll see the next problem, problem number 7. First, I will explain from this. Find the height of a covered box of fixed volume so that the total surface area of the box is minimum, whose base is rectangle and one side is 3 times as long as the other. Therefore, given that the box has a rectangular base with one side is 3 times as long as the other. Let x the first side, that is a smaller side, and 3x be the side of which is the greater one. Let h be the height of the box. H be the height of the box and v be the volume. What about the volume of the box? That is the area of the base into height. The base has, this is the length and this is the breadth, L into B into H. That's why you will get V is equals to 3x square into H. Now differentiate this with respect to x. That's a dV upon dx is equals to 3x square into dh upon dx plus, next is derivative of 3x square and which is the 6x. And for the condition for the maxima and the minima for the second derivative test, with that equals to 0. And if you equate it, then you will get dh upon dx is equals to minus 2h upon x. Let h be the surface area of the box. What is the total surface area of the box that you have learned in the 7th, 8th, 9th standard? That is the S is equals to 2 into 3x square plus 3 into 3xh plus 2 into xh, and sum of this all. That is S is equals to 6x square plus 8xh. Now differentiate this again with respect to S. That is a ds upon dx, which is a 12x plus 8 into. Now differentiation of this using the product rule. X into dh upon dx plus h into ddx of x. That's you are getting, that is a 12x plus 8 in bracket x into dh upon dx plus h. Now substitute the value of this dh upon dx, which is, that is a minus 2h upon x. If we substitute here, then you will get, that is a 12x plus 8 in bracket minus 2h plus h. Therefore, ds upon dx is equals to 12x minus 8h. This is equation number 2. For the minimum surface area or maximum surface area, we always equate the first derivative equal to 0. ds upon dx is equals to 0. It implies that the 12x minus 8h, that is equals to 0. Therefore, h is equals to 3x upon 2. Now differentiate 2 with respect to x. Therefore, differentiate this. The derivative of the 12x is a 12 and here is a minus 8 dh upon dx. And if we substitute the value of dh upon dx, which is the minus 2h upon x, and it's become plus, that is a 12 plus 16h upon x. Both x and h are the positive. That's why from the 3 we get this is the positive quantity and which is the greater than 0. Hence, the surface area of the box is the minimum if the height is equals to 3 upon 2 into shorter side of the base. and that is equal to x. Therefore, this is what that we want to prove. Now we'll start. There is again we'll see here. Find the height of the covered box of a fixed volume so that the total surface area of the box is a minimum, whose base is a rectangle with one side 3 times as long as the other. Given that the box has rectangular base, with one side 3 times as long as other. Let x and 3x be the sides of rectangular base. Let h be the height of box. V be its a volume. Therefore, the volume is L into B into H, or area of the base into height. That is, the area of the base is x into 3x into height is H. That is, V is equals to, we get 3x square into H. Now differentiate this with respect to x. Then you will get dV upon dx is equals to 3x square into dh upon dx plus h into dx of 3x square. That is 3x square dh upon dx plus 6xh, that's equals to 0. Let S be the surface area that is the total surface area, that is a 2 into 3x square plus 2 into 3xh plus 2 into xh, that is a total 6 spaces are there. If you perform the multiplication, then you will get 6x square plus 8xh. Now differentiate this with respect to x, that is a 12x plus 8 into the product rule, that is x into dh upon dx plus h into ddx of x, that is a 12x plus x into dh upon dx plus h, that is a 12x plus x into the value of dh upon dx is minus 2h upon x plus h. And that's why you will get, that is a 12x plus 8 in bracket minus 2h plus h, that is a 12x minus 8h. Now for the minimum, surface area, ds upon dx is equals to 0, 12x minus 8h. Therefore, h is equals to 3x upon 2. Now differentiate that ds upon dx with respect to x. That is a d2s upon dx square, that is a minus 12. That is a 12 minus 8 into dh upon dx. If we substitute the value, then you will get that a minus minus will become plus. Now x and h both are positive, and it's a second derivative is greater than 0. d2x upon dt dx square, by mistake it is a t. The surface area, this is the x square of the box is a minimum if the height is 3 by 2 into shorter side of the base, that is x. Now we'll start the exercise. To complete this exercise, we will require the 7th part of the video, that is, each will be of the 1 hour. Test whether the following functions are increasing or decreasing. That is, first is x cube minus 6x square plus 12x minus 16. For all x belongs to capital R. Now for increasing and the decreasing the given function, find out its derivative. That is x cube minus 6x square plus 12x minus 16. That is a 3x square minus 12x plus 12. Now if we simplify this, that is a 3 in bracket x square minus 4x plus 4. This is the 3 in bracket x minus 2 bracket square, which is positive for all x belongs to set of the real number, and that's why the given function is increasing when its first derivative is greater than or equal to, or you may take like this also, f dash of x is greater than 0 for all x belongs to R, for f dash of x is greater than 0 for all x belongs to. We always write it's greater than or equal to. F is increasing for all x belongs to R minus 2. Answer in the textbook is given in the different way, but I had written like this. If we are agree, then write down this. F of x is equals to 2 minus 3x plus 3x square minus x cube. for x belongs to set of real number, f dash of x is equals to, it's a first derivative, take minus 3 common, then in bracket you will get now this is the negative for all x belongs to set of a real number. F of x is a decreasing for every x belongs to set of real number. If you write it is a less than or equal to, it's also true for this increasing or the decreasing, less than or equal to or greater than or equal to. F of x is equals to x minus 1 upon 2 for our x, the first derivative. Now this is a greater than 0 for every x. Therefore, the f dash of x is a greater than 0 for all x belongs to set of a real number. Therefore, f is a increasing for all x belongs to the set of real number, where x is a not equals to 0. Now I will repeat again here this type of the examples. That is increasing and the decreasing, the first derivative, it's a greater than 0. For the increasing, we will take it's a greater than or equal to, it's maybe that's okay. For it, this is a greater than 0, that's why I had done here r minus 2, and that's why f dash of x is a greater than 0. This is f of x, it's a derivative. Now for the second, f of x is equals to 2 minus 3x plus 3x square minus x cube for x belongs to set of real number. It's a first derivative, its value is a negative. Therefore, the given function is a decreasing for every x belongs to the set of real number. Whatever that you take the value of x, positive or the negative, that is, it's a less than or equal to for the decreasing. But I have taken again here only less than. It's applicable for less than or equal to also. In third case, f of x is equals to x minus 1 upon 2 for x belongs to set of real number and x is not equals to 0. Now f of x, and if you find out it's a first derivative, it's a positive. Therefore, f is a increasing for all x belongs to set of real number where x is not equals to 0. Therefore, for increasing and the decreasing, one thing you remember that for increasing the given function is greater than or equal to, and decreasing is a less than or equal to. You can decide at that time. So, okay. Now we'll start the question number 2. Find the values of x for which the following function are strictly increasing. When we consider it is a strictly, that is, it's a monotonically increasing, then we write the given function is a greater than 0. Okay. And for the increasing and the decreasing, it's a greater than or equal to 0 or less than or equal to 0. This you have to remember. F of x is equals to 2x cube minus 3x square minus 12x plus 6. Now differentiate this. And Here we write f dash of x is a, I had written only here, but I am taking here that's a greater than 0. Then I am here writing here the it's a greater than 0. X is greater than 2 and x is a greater than minus 1. It's clear that x is a greater than 2. Therefore, the given function is increasing for x is a greater than 2. Also, we can take the values of these two are the negative also. Then negative will become positive. Therefore, if we take x minus 2 less than 0, x plus 1 is a less than 0, then x is a less than 2 and x is a less than minus 1. Therefore, x is a whatever that minimum, x is a less than minus 1. Therefore, the given function is a strictly increasing for x is a less than minus 1 and x is a greater than 2. That's why I am again repeating that though here I am written here greater than or equal to, it's a we can write here greater than only. Now see this here again. Find the values of x for which the following functions are f of are strictly increasing. F of x is equals to 2x cube minus 3x square minus 12x plus 6. For strictly increasing, I am again repeating the given function is a greater than 0. That is a 6x square minus 6x minus 12. F dash of x is greater than 0. This I have written greater than 0. Find out its factors. Now this is only increasing, but it is a strictly increasing. Now this is a strictly increasing condition. X minus 2 greater than 0, x plus 1 greater than 0. X is a greater than 2 and x is a greater than minus 1. Therefore, it is clear that x is a greater than 2. Also, x minus 2 is a less than 0 and x plus 1 is a less than minus 1. If we take both of them are negative, then negative will become positive, and that's why x is the less than minus 1, then the given function is a strictly increasing. X is less than minus 1 and x is a greater than 2. This is the answer. Now the next is I am again explaining from here my notes. Now here f of x is equals to 3 plus 3x minus 3x square plus x cube. F of x is equals to 3 plus 3x minus 3x square plus x cube. Now differentiate this with respect to x. The derivative of 3 is 0, 3, 6x plus 3x square. Now again for the strictly increasing, that is the f dash. This is for the increasing and this is for the strictly increasing. We want to find out the strictly increasing. That's why I am writing here that is a 3 minus 6x plus 3x square is a greater than 0. Take 3 as a common. Then in bracket you will get x square minus 2x plus 1. It's a perfect square. Therefore x minus 1 is a positive. For it's a positive, the value of x is a greater than 1. That is a r minus 1. That is the values of for r minus 1, the given function is a increasing. Now see this again here. f of x is equals to 3 plus 3x minus 3x square plus x cube f of x is equals to 3 plus 3x minus 3x square plus x cube. Now differentiate this with respect to x. F dash of x is equals to 3 plus 3x minus 3x square plus x cube. It's a derivative. 3 minus 6x plus 3x square. F dash of x is greater than or equal to 0. But we want the condition it's greater than 0. 3 minus 6x plus 3x square greater than or equal to 0. Now I am writing here it's a strict bracket square therefore this is the strictly greater than condition, that is r minus 1. Now the third one, f of x is equals to x cube minus 6x square minus 36 plus 7. First, f dash 3x square minus 12x minus 36. Take 3 as a common. Then 3 in bracket x minus 6 plus x plus 2 greater than 0. Now here x minus 2 is a condition which is greater than strictly greater than 0. Therefore x is greater than 6 and x is greater than minus 2. It's a greater than 6. Both of them are negative. If we take, then x is less than 6 and x is less than minus 2. And which is the minimum? X minus 2 is the minimum that we will take. Therefore, for the given function to be the increasing, x is greater than 6 and x is less than minus 2. Now, see this again here. F of x is equals to x cube minus 6x square minus 36x plus 7. For strictly increasing, we write here greater than 0. If I write there greater than or equal to 0, it's only for the increasing. But when we find out the answer, we write greater than 0. It's the first derivative is the 3x square minus 12x minus 33, 3 as common. Then in bracket x square minus 4x square minus 4x minus 12, it's a factors. X minus 6 is a greater than 0 and x plus 2 is a greater than 0. X is a greater than 6 or x is a greater than minus 2. And that is x is a greater than 6. And it is a positive again when both of them are negative. X minus 6 is less than 0 and x plus 2 is less than 0. X is less than 6 and x is less than minus 2. That is x is a greater than 6 and x is a less than minus 2. The given function is increasing. Now again, let's see this here. Find the values for which the following functions are strictly decreasing. Then it is a less than 0. Sometimes I write here less than or equal to 0. It is this for the decreasing only. F of x is equals to 2x cube minus 3x square minus 12x plus 6. It's a derivative 6x square minus 12x minus 12. For monotonically strictly decreasing, it's a, by mistake, it is a less than or equal to, but it is only the less than, only less than. That's why I am writing here. Okay. 6x square minus 6x minus 12 is a less than 0. Factorize it. You will get x minus 2 into x plus 1 less than 0. That is x minus 2 less than 0. X plus 1 is it is a negative. Then one of them is a positive and the other is negative. Suppose the first is negative, then second is positive. X minus 2 is less than 0. It means that x is less than 2. X plus 1 is greater than 0. It means that x is greater than minus 1. And that's why once he say that x is less than 2, and here is x is greater than minus 1. That is x is greater than minus 1 and it must be less than minus, it is less than 2. For the second, here we take the first is less than 0. Now we take here the greater than 0. This is the greater than 0. Here we'll take the less than 0. Now here x is a greater than 2 and x is a less than minus 1. But what he say here, x is a greater than 2 and here is x is a less than minus 1. But this is not possible. Then what will the possible? The possible is that the x is greater than minus 1 and x is less than 2. It means that the value of x lies between minus 1 and 2. Again I am writing, for the strictly increasing, the given function first derivative is greater than 0. For the decreasing, the given function is less than 0. By mistake something I had written is a less than or greater than equal to 0, but it is a less than 0. Now we'll see here again the same problem. That is a question number 3. Find the values for which the following functions are strictly decreasing. Again I am repeating here the given function to be the strictly decreasing. If the first derivative is a strictly less than 0. Now this is the first, f of x is equals to 2x cube minus 3x square minus 12x plus 6. It's a first derivative. Now we'll find out. For monotonically decreasing, it's not less than or equal to, it is a strictly less than 0. This is for only the decreasing. That's why I am writing here that 6x square minus 6x minus 12 less than 0. Take 6 as common. X minus 2, as product of these two is negative, one is a negative, another is a positive. X is less than 2 and x is a greater than minus 1. That is x is less than minus 1. X minus 2 is a negative and this is the positive. Now what's happening? X is a greater than 2 and x is a less than minus 1. It's not possible. Therefore, first condition is a possible only. second. First here, see this again here. The problem number 2, f of x is equals to x plus 25 upon x. It's a first derivative. I written here is a strictly less than 0. 1 minus 25 upon x square is a strictly less than 0. Simplify. X square minus 25 is less than 0. Factorize it. This value is a negative. It means that both of them have the different sign. Suppose that x minus 5 is a greater than 0 and x plus 5 is a less than 0. X is a greater than 5 from yes and x is a less than minus 5. How it is possible? This is not possible. Once here you say that x is a greater than 0 and x is less than 5. This is not possible. Therefore, we consider the second. The first we consider this is a positive and this is negative. But secondly, we consider here x minus 5 is a negative and x plus 5 is a positive. Now what's here? If you simplify this, add 5 on both sides. Then you will get x is a less than 5. Add minus 5 on both sides. Then here you will get minus 5 plus 5 get cancelled. There is a minus 5. X is a greater than minus 5. This is a possible. Once he say that x is less than 5 and he say that x is a greater than minus 5. Yes, this is possible. Therefore, x is not equals to 0 and that's why we have the values. That is a x lies between, that is a minus 5 to plus 5 and not equals to 0 also. Other than 0. Now see this again here. If you take the value of the x is equals to 0, that is the 25 upon x is not possible. 0 is not possible. F of x is equals to x plus 25 upon x. Derivative of x is 1. Minus 25 upon x square less than 0. One minus 25 upon x square. It's a negative. If we simplify it, x minus 5 into x plus 5 is less than 0. X minus 5 is greater than 0. And x plus 5. One is positive, another is negative. Add 5 on both sides, and you will get x is greater than 5. Add minus 5 on both sides, x is less than minus 5. X is greater than 5, and x is less than 5. But what's happening here? This is not possible. Now, in second case, x is this is negative and this is a positive. This is possible. The values of x is lies between. And what about here? This is not possible. Now the third one. See this again, third example. F of x is equals to x cube minus 9x square plus 24x plus 12. F of x is equals to x cube minus 9x square plus 24x plus 12. First derivative. That is a 3x square minus 18x plus 24. F dash of x is less than 0. Take 3 as common or divide on both sides by 3x square minus 6x plus 8 less than 0. Factorize it. Now the product of these two brackets is negative. It means that both of them have the opposite sign. In first case, we consider x minus 4 is negative and x minus 2 is a positive. X minus 4 is less than 0. Add 4 on both sides. Then you will get minus 4 plus 4 get cancelled. 0 plus 4. That is x is less than 4. And what about here? Add plus 2 on both sides. It means that x is a greater than 2 and here is a x is a less than 4. The value of x lies between 2 to 4. In another case, we consider here is x, we consider x is negative. Now here we consider secondly positive and here as we consider positive, now here we consider the negative. Now x minus 4 is a positive, add plus 4 on both sides for this. Then x is greater than 4 And what about here? Add 2 on both sides, x is less than 2. Once he said that x is greater than 4 and here he said that x is less than 2, this is not possible. Which is a possible? The first case is possible. The values of x lies between 2 to 4 is possible. That is x is belongs to 2 to 4. This is the answer. Now we'll see here. Again, f of x is equals to x cube minus 9x square plus 24x plus 12. X cube minus 9x square plus 24x plus 12. F dash of x is equals to, for the decreasing, f dash of x is less than 0. 3x square minus 18x plus 24 is less than 0. If we take 3 as a common, then x square minus 6x plus 8 less than 0. Factorize it. X minus 4 into x minus 2 is a negative. As it is a negative, both of them have opposite sign. Thus x minus 4 is a negative and x minus 2 is a positive. If we solve this, add 4 on both sides, then you will get x is less than 4. Add 2 on both sides, x is greater than 2. Therefore, the value of x lies between 2 to 4. If we consider the second case, that is x minus 2 is a positive, x minus 4 is positive, x minus 2 is a negative, then you will get, add 4 on both sides, then you will get x is greater than 4 and x is less than 2. This is not possible. And therefore, the first case is possible and x lies between 2 to 4. And in this way, that is again see this here, or it says that is minus 5 to plus 5 and minus. Now in this way we have completed up to the question number 3. Now the remaining questions will be in the next video. This is the biggest exercise and it is complicated, and that's why I had made 7 parts. Each part is for the 1 hour. Now we'll see in the next video. Till then, goodbye.